Thank me later for the story.
Okay guys, so 8A.2. Today we're graphing the exponential functions. I need to actually give you the official definition of an exponential function though. It is defined by y equals b to the power of x. That is called an exponential function with base b. So that's where the whole base thing comes in. Okay? Now, there are two requirements. Oh my God. Number one requirement is the base can never equal 1. So b cannot equal 1. Okay? The base must also be positive. So the base must be greater than 0. Now that does not mean that your base cannot be a fraction. Okay? You can have a fraction as your base. However, you just cannot let it equal 1. Okay? So it can be any positive number, just not 1. So, for example, y equals 3 to the power of x is an acceptable exponential function because the base here is 3. All right, guys, so example 1. What we're going to do is I'm giving you an exponential function, the one that we've already looked at, y equals 3 to the x, and we are going to graph this function by making a table. So if you are ever asked to specifically graph a function, what you want to do is set up a t-chart like I have written up here, and you're going to always plug in the same 5 values for x. 2, 1, 0, negative 1, negative 2. So we're going to take those x values and plug them into the function for x, which is your exponent, and it's going to spit out a y for us, and then we'll be able to graph. Okay? So, if my x is 2, that means I'm going to be taking 3 to the power of 2, which gives me what? 9. If x is 1, that's going to be 3 to the power of 1, which is 3. This one is kind of nice. X is 0, so 3 to the 0 power is? Anything to the power of 0 is? 1. Thank you. And then this is where it gets kind of interesting. My x is negative 1, so I have 3 to the power of negative 1. So what would that make y? 1 over 3. So then what would 3 to the negative 2 be? 1 over 9. It will always turn out this way. Okay? So what we're going to do next is we're going to graph those. So let's take 2, 9 first. So my x is 2 and my y is 9. So on my graph that's going to be up here. The second point is 1 and 3. So on my graph 1 and then up 3 right here. 0, 1 is always going to be a point. So you can always count on 0, 1. And then this is where it gets tricky. Negative 1 is your x, and 1/3 is your y. So that's above the x-axis, somewhere in between 0 and 1. Just estimate. Same thing with 1 over 9. My x is negative 2, and my y is 1 over 9. So that's still right above the x-axis. So what does this actually look like? It's a curve.
J.
It's like a backwards J, right? Now the thing about exponential functions, remember how I told you earlier in your notes that x has to be, not x, I'm sorry, the base has to be a positive number greater than 0? Because our base is always a positive number, your exponential graph will never cross or touch the x-axis. So I want you to write that note. It will never cross the x-axis. Okay? So an exponential function, the graph will never ever cross the x-axis. It will get really, really, really close. You might have a y value that's like 1 over 100. That's really close to the x-axis, but it never actually touches. Okay? Okay, so since my base is 1 over 5, if my exponent was 2, that would be 1 over 5 squared. So what would my y be? Thank you, 1 over 25. What if my exponent was 1? 1 over 5. Anything to the power of 0 is always 1. So then if I have 1 over 5 to the negative 1, what would my y come out to? 5. So what would my x of negative 2 be? 25. They will always mirror each other in that way. So when I graph this, 2 and 1 over 25. So that's going to be positive 2. 1 over 25 is really close to the axis. 1 and 1/5 is also really close, but a little bit higher up. 0, 1. Negative 1 and 5. So negative 1, 1, 2, 3, 4, 5 right here. And then negative 2 and positive 25 goes off my graph, so I'm not going to worry about it in this case. I'm just going to make sure that it grows really, really fast. So my graph will actually look something like that. Okay? So it's continuing on to go as close as possible to the x-axis, but never actually touches the x-axis. Okay? Not too bad? So anytime you're asked to graph one of these things, you can just go ahead and use the table for those. Okay. Now that you guys have graphed 2 of these, we have 2 kinds of exponential functions. They either look like this, getting close to the x-axis and then growing upwards, or starting away from the x-axis and getting closer and closer as you go down. So there's 2 types of exponential functions that we will be working with. I also want you to note that these are smooth curves, meaning that if you are actually plotting points, you're not going to draw straight lines in between each point. You want to try and make the curve as smooth as possible. Okay, so because we have 2 types of graph, we have special names for each one. We have what we call decreasing exponential functions and increasing. The graphs are called decreasing if as you go from left to right, they drop. Okay? So one thing I want to make sure that you guys remember is, you know how when we're reading, we read from left to right? You also read graphs from left to right. So if we are going from left to right and the graph is getting closer and closer to the x-axis, that's called decreasing. So we would say that as x gets larger, the graph gets closer to the x-axis. Increasing is the opposite. So graphs are called increasing if they rise as you go from left to right. So on increasing graphs, as x gets larger, the graph gets further from the x-axis. Okay, so example 3 is the types of questions that you're going to see on the test and on your homework for these types of problems. So here's what it says. If the equation y equals 5 to the x is graphed, which of the following values of x would produce a point closest, and that's very important, closest to the x-axis? And then they give you 4 values of x. Okay? So what I do in these problems is I try to sketch the graph so that I can figure out if it's increasing or decreasing. That's really what we're looking for here. Okay, so I want to sketch the graph to determine if it's an increasing graph or a decreasing graph. So what I do is I do the t-chart. But I'm only going to pick 3 terms, 2, 0, and let's do -2. I'm not going to do all 5 because this is just a sketch to answer the question. So if my x is 2, that would be 5 to the second power, which would give me what? 25. So when I graph that, 225 is actually off the chart somewhere over here. 0 is always going to be 1. So your point is going to be somewhere here. Okay. And then if my exponent is -2, what would my y be? 1/25. Good. So if I wanted to graph that, that would be -2 and somewhere really close to the x-axis. So if I wanted to draw the line, it's going to look something like this. So is that an increasing graph or a decreasing graph? Remember, we read from left to right. Increasing. So this one is increasing. Write that note. Okay, so if this graph is increasing, that means as x gets bigger, my y's get bigger or smaller? If I'm going to the right, x is getting bigger, are my y's getting bigger or smaller? They're getting bigger because they're going up. So which of the following values would produce a point closest to the x-axis? If I'm trying to get closer to the x-axis, do I want x's to be big or small? Small. So of all of our answer choices, A, B, C, and D, which one is the smallest? -1. So in these types of problems, your answer will always either be the biggest number or the smallest number. Okay? But you're basically looking to see if it's increasing or decreasing first.
What would it look like if one of the answers were
Look at my equation here. Y equals 1/3 to the x power. Which of the following would produce a point closest? When my base was 5, it was not a fraction. Was that an increasing or a decreasing graph? Do you guys remember? The one that we just did, it looked like this. That's increasing. If my base is a fraction, what type of graph do you think it will be? It'll be decreasing. So fractions equals decreasing graph. Decrease. So fractions equal decreasing. So this graph is actually going to look like this. So if I'm looking for the closest value to the x-axis, am I this time looking for the smallest x or the biggest x? The biggest x. So look at your answer choices, A, B, C, and D. Which one is biggest? B? I hear some C and I hear some D. D is 7/4. How can you rewrite 7/4? 1 and 3/4, right? Is 1 and 3/4 bigger or 2/3 bigger? 1 and 3/4, so your answer is D. Okay, so if you have a fraction, your graph is decreasing. If it's just a number, your graph is increasing. Okay, so last example for this set. Which multiple choice ordered pair represents the y-intercept, that's the key word here, for the function y equals 2 to the x? And then they give you 4 points, 0, 0, 0, 1, 0, 2, or there is no y-intercept. So what do you guys notice about all of your answer choices? They all have 0 for what? For x. So why don't we plug in 0 for x and see what happens? If I have y equals 2 to the 0, what does that give me? Y equals 1. So which point is 0, 1? B. There definitely is a y-intercept with exponential functions, but there is not a what? If it never crosses the x-axis, there's not an x-intercept, right?
Yeah.
Y-intercept means it's crossing the y-axis. X-intercept means it's crossing the x-axis, but it never crosses the x, ever. Okay?